So, hi everyone. In this video, we'll be discussing Codeforces Round 1074, that is of day 4. Before moving forward, I have two things. First of all, I'm really sorry that I can't live stream daily um, as I intended, or I said in some comment I'll be streaming daily because there was some things messed up and I had to sort it out. Um, yeah, the second thing is it really feels good that I'm making yet another video explaining my solutions or how I thought during the contest. It's really feels great. Yeah. So apart from that, let's just dive in and see what the problems were. Um, the first problem is relatively easy. So given n, given an input n, you have to print x numbers such that x is an perfect root. As you can see, every number can be a perfect root for a square. Say if I take any number k, then it would be a perfect number for a perfect square root for k square. So yeah, we can just display any arbitrary n numbers and that would suffice. Just if you want to see the code, yeah, that's pretty much it. And yeah, most of, I mean, it's relatively easy. So moving forward with the second problem. The second problem says the prefix max. I don't know why it is lagging, but yeah, let me guess what the question is. Mm, yeah, the question is we are given an integers, and then the value of an array is sum of the maximum of each prefix array. More formally, the value of an array is summation I is equal to n. You can choose two indices I and j and swap elements e and ej. The operation can so basically the idea is that we know the prefix array is from I to 1 to I. Then we have to um, report the summation of max of prefix up to 1 or plus max of prefix up to 2 and so on till prefix up to n, and we are given an operation that we can choose any two indices and then swap ai and aj, and this can be applied at most one. So as if we think greedily, the best way to maximize our score is to swap the largest element. Say in this array, if I choose to swap 5, then all of my max prefix maxes would be 5. Then it would give 5 into length of the array, that is 5, that is 25. The same goes here, and yeah, the code is as simple as that. We find the maximum in the array, then we just output it like max c into n, that is the number of array, because there will be n prefix arrays possible for the given array. And moving, we could move forward actually. uh, my internet is a bit slow, but will be doing, I mean, the problem a b c d, and even, I mean, e was quite interesting. I mean, it was good, a bit um, implementation. Then f was the way I did f, and then G is really a good problem, I would say. Yeah, let me just do this thing so that we have all the problem loaded. Yeah, yeah. So in C, what we know is that we're given an array of length n, a1 to an, and we are allowed to perform the following operation once. Select an integer x which may be negative, and then for each value I is equal to 1 to n, set ai is equal to ai plus x. And after this, once I mean, we can do this operation once, right? And then we have to output the maximum possible value of max. Max, if you don't know, it's maximum excluded element. Yeah, it defines the smallest non-negative integer that is not present in the array. So we'll be using whiteboard here. The thing is, say we are given you have an array, right? Let suppose a1, a2, so forth, so forth. Like a1 is a number, a2 is a number, then an, right? And we have to report the max. What we can do is we can arbitrarily choose an integer x. It may be -2. Then what we can do is that I can do I can transform my array as a1 plus x, comma a2 plus x, so on till an, right? I mean not an plus x. And after I make this transformation, I have to report the max of this array. Okay, so great. So if you if we deep dive into the meaning of max is maximum excluded number. Say I have, say, 0, 1, 2, 4. Then here the largest non-negative element that is missing from my array is 3, right? We don't have 3, we have 0, I have 1 or 2. If say I have 1, 2, 3, 4, then the maximum excluded number would be 0, as we don't have 0, right? The non-negative integer. For this the max would be 3, for it would be 0. So what do we see? If we have any k contiguous numbers, then what I can transform is that if I subtract -1 from here, it would become 0, it would become 1, it would become 2, it would become 3, and then the max would be 4, right? The same thing, we have to find the longest contiguous I mean, it need not to be like this, it could be even 4, 1, 2, 3, then yet the max would be 0, right? The thing we want to do is to find the longest contiguous number, and then we'll be subtracting the base. Say the base is 1, I mean 1 here as in the starting number. Say if it was 6, 7, 8, 9, 10, then I would be subtracting 6 from here, 6 from here, so it would be leading 1, 2, 3, 4 and 5. Sorry, it's my bad. So it should not start with 1, rather it should be 0, 1, 2, 3 and then 4, and we'll be having 5 as our max. So that's pretty much what we do in our third solution. We sort the array, then we find the longest possible length that is stored in res, and then my answer would be the res itself, right? Because say if my longest array is of size 5, then my max would be 5. That's pretty much it. I hope we are on the same page and we can proceed forward for problem D. So Bessie as an array of n integers a1 to an, Bessie performs m operation on the array. The add operation sets abi to abi plus ci. Unfortunately, due to RAM costs, Bessie's computer has limited memory, and whenever an element of array is greater than h, her computer crashes. Every element in the array resets to its original value after all operations are performed. Output the array. Okay, so what the problem says is that we are given an array a1 to an, right? And we have to perform q operations. In each operation, I'll be providing you with the index and then the value. What you have to do is that you pick the element with this index and increment it value by val. Say I give you index 3 and value is 6, then you pick a3 and you set it as a3 plus 6. and we are also given a constant h. Whenever any of the value in this array during any operation goes beyond h, if a3 or ak is greater than h, then we have to reset the array, right? So if you do it in a naive way in D, you could be having something like that. Um, Vector ll array n, then you would be looking for auto a array you input it, then you would be having vector ls for n, then v for LLI equal to 0 I less than qi, plus will be taking LLI dx, then we will be taking value in idx. Well, we have 0 base, so we'll be taking idx, then you would be doing current of idx plus equal to val, and then if current of idx is greater than h, then what you're doing is that I mean, it's as simple as this, but the problem is that you see this operation, the current is equal to array. This operation costs O of n time. And if at worst time complexity, we'll be having O of n cross q, right? You see, the loop here goes till q, and if every iteration in the loop I hit this condition, I would be having I'll be performing this operation. This operation would take O of n time, right? And which is not. I mean, we'll get a TLE, as simple as that. Because if you see the constraints in D, um, both can go up to 2e5, and then yeah, if both can go up to 2e5, then I mean, not exactly both can never go up to 2e5. I mean, the sum can be of some can some will not exceed 2e5. Say we have 1e5, 1e5, but 1e5 into 1e5 is, you know what, 1e10, and which you clearly gives you a TLE, right? So the one thing or optimization which I want to do here is that why would I be changing every element? I'd just be changing the element I accessed or I modified, right? I'd be setting them to 0, and uh, rather than having up to array of n, I would be having, rather than maintaining this array as n or current as n, I would be rather want to have something as add n. This is the value we want to add to array n, and our checking condition would be add x plus add x, and I would be having a set of numbers that is touched, and then the touched refers to the elements we actually touched upon or we interacted with, and every time we hit the condition, every elements we touched, the add of it would be 0, and then I'll be clearing the touch, and this should efficiently taking O of n cross, I mean, this time complexity would be O of n plus m log m. Sorry, should be m plus n log n, which is m is the number of operations, and then n is the size of the array, and yeah, which would suffice, right? N log n is 2e5, and I mean m plus n never goes. You get the idea, right? We want to have two things. One is array, the initial array we are given. Then we have add. Moving forward, every time I touch an element, I'll insert it to the touch, and then I'll be checking the condition. If the condition hits, if I want to reset, I'll just reset the add part, and then I'll removing all the elements from the touched, and I'll be moving forward. Yeah, to report back, we just report, or rather, we just do array of I plus equal to array of I, then I'll be printing out the array of I. I hope we understood. I'll be taking a quick break here. How do I pause here? Can I pause? Stop recording. Yeah. I don't know if I can. Yeah, I can pause here. Yeah. I'm back. So the what I was saying, it was not G. Yeah, E. So we discussed ABCD. Now moving forward to the E. I'm not going to read all these things. I'll just explain you the problem itself. But the problem says is that we have few robots, say from mm, a line, uh, in a line, right? And we're given their position. Say this is P1, then another robot is in P2, then P3, and so on till Pn. Then we have Q spikes. Say spike 1, spike 2, oh, spike 2, then we can have spike 3, spike 4, spike 5, and we are given K instruction. Say instruction is in format either L or R. Say we have L, R, L, 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 R. So what this instruction mean is that every time we hit an, I mean, we follow this instruction one by one. So if we have an instruction L, then every robot will move one unit left. Say earlier P1 was 4, then it would be 3. Then after processing this instruction right, it will again move back to here, right, and then left it will go back to 3, go back to 2, go back to 1, then come back to 2, right? If it was 4, then it would be go to, after this instruction it would be 3, then 4, then 3, then 2, then 1, then 2. You get it, right? And if in all of this instruction, anytime any robot touches the spike, that dies instantly, and we have to report after processing, say, I instructions, how many robots are alive, right? We get the question, right? Hopefully. I think we don't have a diagram here, but no problem. If we're able to understand this question, be moving forward for the answer or the how we gonna solve it. See, let's think, right? If I have something, say, and prefix array, prefix I says how many robots are dead after I turn, then I can definitely know how many robots are alive after I turn. It would be just n minus pref of I, right? N is the number of robots. Okay, cool. So how am I gonna process this prefix of I is the question, right? Prefix of I refers to the number of robots that are dead after processing I number of instructions. I hope we are crystal clear till this point. And then n minus pref of I would be the number of robots that are alive after processing I instructions. Cool. Okay. So if we go in a naive way, right, then what we can do is that we process an instruction, we update the value, right, and then check whether at this point there is a spike or not. If there is a spike, the robot dies, and then we'll be reducing it. I mean, it can simply take up to say, if you I mean, um, we have to process K instruction, which is 25. Then we have n robots, which is to e5, then k into n takes order of 10 ki power 10, say, then we have m, and 10 ki power 5 elements in an ordered set doesn't seem good, so you'd be using a normal set or tree based set, and lookup in a tree based set takes log n time, log m time, then it would be n into k into log m, which is way higher, and we'll be getting a TLE very simply, right? So yeah, obviously we'll not be moving forward with this approach, at least as of now. So I want you to think about this thing. If for a particular robot, what is the most uh, important thing we should be worried about, since this is a robot R? It would be either dying to a spike to its left or dying to a spike to its right. Say this is spike k, this is spike k plus 1. For we know for sure that this robot, if it dies, will either die to this spike, I mean to this position, or either die to this spike, right? Okay. And once the robot dies, it wouldn't be moving forward, right? I mean, it wouldn't be participate, it's dead. So if I say to reach to this point, the robot need k1 instructions, and to reach to this point, the robot need k2 number of instructions. Okay, if I give you the value of k1 and k2, can you tell me at which instruction the robot will die? The answer would be the minimum of k1 and k2, right? If it dies, it might be possible that it can just oscillate in between and it stays alive till the point, right? But for the condition, say if there exists such a set of instruction that after k1 points the robot is available to, not available, it's rather able to reach sk, and after k2 instruction the robot is able to reach sk plus 1, then the index where the robot will die is minimum of k1 and k2. Okay, so we're able to find this thing. And the second thing I want to mention is that, well, at process L1 and R1, I can have two kind of maps, say the MP1 and MP2. What this MP1 tells is that after how many instructions I have processed, uh, I'm able to reach, say, if I want to mess up like this, I want to keep two maps, say L1 or say L and R. Lx says Lx equal to y represents the number of instructions. Y is the number of instruction, or minimum number of instruction to be more precise, to reach a point x distance left to any given point, right? Say if L2 represent the minimum number of instruction I require to move 2 units left, L3 represent the number of instruction required to move 3 steps left, L4 represents number of instruction I need to follow in order to reach a point that is to left of me at a distance 4, and so on. And the same goes for R. Say R5 means the minimum number of instruction I would require to reach a point that is at a 5 distance to the right hand side of me. If we have all these tools, then I'm definitely able to solve this in a way quicker time. How are we going to do that? Is where we need to look at the code. we have an array, the robot positions, then we have um, spikes. I would like to maintain them in set because I would be then able to perform binary search upon them easily. We can definitely have it in array and then we can sort it and perform binary search, but set in by default provides an lower bound. Yeah, I mean there is lower bound for array, but I don't know if it's like n log n or something else. I'd be looking forward to it because array can be unsorted, and I don't know for sure first time it sorts and then takes login time or uh, anything. Yeah, but yeah, for set then I know if the lower bound definitely takes O of login at max, right? Then I'll be inputting all my element, then spikes, then the same thing I described, the left and right maps. I'll be filling them up after processing all the instructions. And yeah, the prefix array dead I mentioned earlier. Then I'll be processing each element. Then we have auto iter is equal to spikes dot lower bound it, but it says that if I give a robot position x, tell me the position of spike that is just right to it. That we can definitely, and yeah, we are given a constraint that no two robots or spikes position coincide. So if I find the lower bound on x on spikes, set spikes, it would be giving me the iterator, which is with points to the spike that is right side to my position. And if it is not spikes dot n, then my right would be simply the absolute distance in between them. The same goes for the left, but you have just to be careful with the condition that if say we have an element x, this is the first I mean this is a robot, and then this is a spike one. There are no spikes before, then the left would be simply, I mean there are no spikes to the left. I mean no matter how left the x travels, it would not die. So we just have to take in condition for both of them. Then we'll be having left equal to -1, then right equal to -1. And yeah, LLIDX is k is just in default value. You can have it something as that. The You can have a conditional or a flag like robot is alive, and if you hit any of these condition, then we'll be proceeding as robot is dead, and then we'll be putting it in dead array. But case seems an intelligent or not rather intelligent, or it's a basic trick, so that I'd be putting it in my last uh, index so that it stays alive till the iteration k plus 1. So it doesn't matter. Yeah, we'd just be checking forward, and the dead index would be incrementing by 1. Then we would be doing a prefix something, and after that we'd be printing out the number of alive. Yeah, so to summarize, we have two maps that I described. Map L represent number of instruction it need to possess before reaching a point uh, x in L, and the same in R. Then we'll be having a binary search, and yeah, the prefix array, and then the number of alive. I hope we are done here, and I don't even want this. Yeah, this is the E problem. Now we can move to the F problem. F problem um, is very simple if you have a bit of understanding of segment tree. At least I did it in that way. So what the problem says is that we have 2 raised to the power n cows. Each cow compete with its neighbor. Say cow 1 would compete with cow 2, cow 3 would compete with cow 4, and so on, right? And eventually they will end up merging into one. Say rather I would just be taking the second board. Say this is cow 1, this is cow 2, this is cow 3, this is cow 4, So they'll first fight with each other. I mean, the question doesn't say this, but yeah, it literally means this if you just uh, turn those like if you just think a bit and change the problem statement. So once they fight with each other, there will be some thing, and after that they will merge into one stack and eventually continue till they go to the top, right? And which is definitely an like how the segment tree is. What the question asked me to do is that it will be first having an array, then say array was there will be some value associated with it, say this is a1, a2, a3, a4, and what they require is that they will be giving me q queries. In each query they'll give me an index and then a value. What I can do is what I need to do is that for the given index I need to change the original value, what it is in original, to this value, and then I need to perform few operations on them, and after that, after its all its operation, I need to tell the number of cows that are stacked. I think it's above, right? Output, how many cows are above the cow that was given in the final line. So to put it very simply, and how do I know if a cow is above our current cow or below our current cow is that say our current cow stack, initially our current cow is in, I mean the current cow stack is in current cow stack there is only current cow, say it was 3, and it was then, or rather I just need one more board. Say my current cow stack contains the current cow, which is value is 3, right? What it needed to have this awesome, right? Yeah. Yeah, it's awesome, yeah. And mm, each cow okay, ठीक है. अच्छा, the stack with high skill level will win the match. The winning stack will jump on top of the losing stack. Okay, yeah. So the thing is, uh, say initially all cows will start with the initial, and they'll fight with this. So as you can see, the Zorsum here is 3, and the Zorsum here is 4. So it wins. So it would be jump above here. So it would making 4, and both of these Zorsum would lead to 7. Say there is another thing. Say this is 2, this is 4. Then there's Zorsum is 6. So they will be down, and then it would get stacked upon here. Yeah, so the operations are pretty standard or equivalent what you do in a segment tree. So initially in segment tree you can have queries, and each query would evaluate going from top down. Say you will move below, and if you say it's in range, I'll give me the value here and give me the value here, and you just pass it you till you reach the root of the segment tree, and then you return out its value, right? The same thing is done here. If you see, we just have a standard segment tree. This is a template. I didn't wrote it. It's somewhere saved for me. It's in Zor segment tree, and then we have a query, right? So this is a standard query that you asked with Zor segment tree, and this is the Q2 I have written for this question, right? Yeah. So if my left is equal to right, or then I'd be just returning the 0, right? then then I have to go to the mid, that is left plus right by 2. The answer would be 0. If my position is less than equal to mid, right, like the position here refers to the point where my current, you know, or the index I am querying for. Say if my position is less than equal to mid, say my mid is here, my position is here, then I'll be querying uh, how many actually trees are up to, like here, what is the XOR sum of this thing and what is the XOR sum of this thing. If this wins, right, if this wins, or say if the segment B, let's call this as seg A and this as seg B, if this wins it move on top of this, so my answer would consider will be incremented by seg B. But in the later case, say my position is somewhere here, uh, say my position is somewhere here and we have this, say then this would be seg A, then this would be seg B. If seg A is greater than or equal to seg B, I mean, on the case of equality, the left one wins, so it would definitely go on top of this. So we have this conditional here, and we go to the deeper levels. That's pretty much it in this question. Now, for the last problem, yeah. So for the last problem, I don't think I'll be explaining in this video because it's a pretty lengthy question, and yeah, I'll be making a separate video on it. I think, yeah, it's a long thing. I need you to explain the question and how you can actually come up with this thing. So yeah, I think I'll preferably make a separate video for it so that I could explain you better. I don't know if I'm able to translate myself properly, but yeah, if you think I'm lacking on something, I need to explain, or if you have any suggestion for me, that is really welcomed from your side. Yeah, that's pretty much for it in this video.